Hello everyone, it's me Gagan Kumar present over here to teach you physics. Let's move on to the video. Today we'll be discussing block over block problems. In the last lecture already we have completed friction. In this lecture we'll see some application. So there are two blocks M1 and M2 and here there is some friction between M1 and M2, and if you are applying a force here, then some maximum force, some acceleration, okay, moving together condition. So this type of things will calculate here. Okay, so let me go for a fresh page. And here let me write heading. So block over block problems. Okay, so understand here what now situation is like this. So there is a floor. In this floor you are having a block M1 and here you are having block how much M2. Now between M1 and M2 there is a coefficient of friction, so how much it is? Mu. Now you are applying a force on what? On M2. While you are applying M2, you continue. Okay, now here what asking? Now here asking find the maximum value of F, F such that both blocks will move together. Both blocks will move together. Both blocks will move together. So this is the condition they're asking. Now understand here, and here this is basically taken a smooth surface. Here you take a smooth surface. Now here you have to apply a force on M2 so that both block M1 and M2 will move. Okay. Okay. Now listen here. Here what we'll do, now solution will do like this. Now first we do free body diagram of M1. Free body diagram of M1. So M1 is here. M1 is here. Now understand, for M1 there is one reaction, normal reaction N upward, and one is M1G, it is vertically downward. Yes or no? And here what is happening now? Here this force is acting on M2, but here this is the contact surface. This should be, due to this contact surface, there what will happen now? Here one frictional force will come. So at this surface one frictional force is coming. How much it is? Now it is here. How much? Tell that frictional force. Frictional force is F. And how this F is acting here? Now see, F will act in this way. F will act in this way. Why it will act in this way? To forward direction, because force is acting on M2. So M2 will try to move. So friction will try, or friction will tell to M1 that you also move with M2. You also move with M2. Yes or no? You also move with M2. So that's why what is happening here? Here it is happening, frictional force is acting in the direction of F, because both should move together. This one friction will want, and here one minute another also normal reaction due to M2, another normal reaction will be there on M1. How it is? Not like N prime, it will be like this, but we will not talk about this one. You just omit this vertical forces, you omit, only just understand here horizontal direction, one M1, on M1 there is a frictional force which is acting in the forward direction. Why? Now because force is acting on M2, now friction will tell to M1 that you should move with M2, because friction always opposes relative motion. That's why friction will act in such a that it will try to move the M1. So here the force is this much, and acceleration how much? Now here acceleration you can tell, acceleration is A in this direction, and you can write F equal to how much? M1 into A. Now similarly, if I will do free body diagram of M2, then how much I will get here? Now see here, M2. So on M2, what is the force acting? A force is acting F, that is applied force capital F, and one frictional force will act. It will be how it will act? Now this is the contact surface, so frictional force acts parallel to the contact surface. So it will act in this way. Why it will act in this way? Now frictional force will tell to M2 that M1 is at rest, so you don't move. You be at rest, such that both M1 and M2 will be together. M1 and M2 will be together, because friction always opposes relative motion. Because friction does not want between these two motion should happen. Does not want. Now here acceleration, how much? Acceleration is A in the direction of forward direction, because you are telling both should move together. So both the acceleration is same, and we are considering this acceleration is forward direction or right side direction. Yes or no? Now here if you get Newton's laws of motion, what will get here? F minus F equal to how much? M2A. Okay. Now understand. Frictional force is between M1 and M2 or M1 and floor? Frictional force is between M1 and M2 or M1 and floor? Between M1 and M2, because here rough surface, here it is smooth surface. So if you want to find the frictional force here, you want to find normal reaction here also. Now see, if this frictional force you want to find, then what is the normal reaction? Now for M2, then the M2G will be downward. Yes or no? And N will be upward. Yes or no? Now frictional force is how much will come here? Now frictional force will come M2 into G into what? Mu. Yes or no? Okay. Here you just write first. Right here. What is your F? Now your F equal to nothing but your F equal to mu into M2 into G equal to how much? M1 into A. Now from here M1, M2 nothing will get cancelled. You find just acceleration value. What is acceleration coming? Tell me. Acceleration coming mu M2 by M1 into G. This is the acceleration. Now here in this case, if you force you want to find, what is this force? That is F plus M2A. F is how much? It is F is there is M1A, right? So M1 plus M2 into A, because F equal to how much? M1A also. F also mu M2G. Now here what you do, in place of A, substitute this value. But substitute this value, how much will come? See, mu G will come, and here what you have? Now M2. Okay, or write together, right? Mu G M2 by M1 into how much? M1 plus M2. M2 by M1 into M1 plus M2. So here if I want to find maximum force condition, then maximum force condition is this one. If a little I will modify this, what I can tell? Now my maximum force just to move together, or two blocks will move together. What is the maximum force condition? Now here M2 you can take inside also, no risk. Yes or no? Or M2 by M1 you can multiply. If M2 by M1 will multiply, how much will get? Mu G will be there. It will be M1 plus M2 square by M1 will cancel. I think it is M2. It is M2. See, M1 cancel. M2 plus M2 square by M1. Yes or no? Right, this expression you just multiply and tell here. So it will be M2. M1 cancel, because when M2 by M1 will multiply there, then M2 plus M2 square by M1. Okay. Or little if you want to modify this expression, you can modify also. F max equal to how much? Mu G M1 M2 plus M2 square divided by M1. So this also you can tell. F max. So either use this formula F max or this formula, whatever you use. Okay, get it, answer. So what is the common acceleration? Now common acceleration is this one. If you both are moving together, then common acceleration how much? Now the common acceleration they are moving. Common acceleration how much? A will be equal to mu into m2 by m1 into, okay. So this is your maximum force. Both the body will move together. Okay. And minimum how much? Minimum greater than 0. That means to move together, total condition what can be? To move together, your condition is coming, your force should be greater than 0 and less than equal to F max. Less than equal to, okay. So this should be to move together condition. Okay. This one you must remember. That means here, if F max is 30 Newton, okay, suppose for example, then here if you are giving 2 Newton also, they all will move together. Okay. Suppose F max is how much? 30 Newton. 2 Newton is what? Less than F max. That means both will move together. Okay. Because maximum value is this one you calculated. Because why maximum value? Because the starting friction value, whatever condition you took here, the starting friction, maximum starting friction you took. Okay. And you are thinking this is the thing is happening. Okay. Yes or no? So this is your F is acting where? On M2, upper block. So remember, this is your upper block. This is your lower block. So block over block problems. Yes or no? Now similar case we can have when this F will act on M1, then another F max condition will get. Okay. So in the previous slide I'll show you. So first you note it down. That one I'll just explain. Clear, ma? Okay. Now you do one small question here. All concepts are there. Just you tell me. So here one block is there. Here over this block another block is there. This is 2 kg. This is 6 kg. 6 kg. And here coefficient of friction mu value is given 0.1. How much, ma? 0.1. Now find here force is acting here, force is acting here, F. See, this F can act like this, or from here also you can write like this one, F is acting. Okay, so you can do that also. So F is acting on 2 kg block. Now the maximum force or the maximum value of F such that 2 kg and 6 kg will move together. Will move how much? together is option A. To calculate option A, B, C, D, I'll give. You try find. Already formula is given. Okay. So simple thing you just apply here. This is your M2. This is your M1. Now substitute M1 into M2 how much? 6 into 12. 12 plus 2 square 4. So how much? 16. 16 by 6. 16 by 6 means it is 8 by 3 and mu into g will come how much? 1. And if you want to find also what is common acceleration here, so common acceleration can be mu into g, that is 1, and m2 is how much? 2, m1 is 6, so it is 1 by 3. Okay, 2 by 6 how much? 1 by 3. That is your common acceleration. Okay, so this much idea remember. So same case, if here f is acting on m1, then what is the condition? Now this condition directly understand here. So here direct condition is what? Now if f is acting on m1, then similar free body diagram of m2 and m1 you do, and maximum condition of force is coming how much? m1 plus m2 into mu g. Okay, so remember here. So here what is the f max coming? F max is nothing but m1 plus m2 into mu g. So this is the maximum force condition for this situation. Like f is like what? Directly contact with the m1. F is directly contact with m1. Okay. So f is equal to how much? m1 plus m2 into mu g. That is the maximum force. And here common acceleration how much? Now here common acceleration you want to find. If all are moving together, then a equal to nothing but mu into g. Mu into g. This is your common acceleration. This both are moving. If f is acting to lower block, remember this is what? This is your lower block, and that one is upper block. So it is your upper block. Upper block. It is your lower block. Okay. So if you see f is acting where? Yes or no? Now just understand another thing here. So here also same thing you did, a 5 kg, 10 kg block is there. Mu is given 0.2. Now here what is the maximum force is happening here? 30 Newton. Okay. Now suppose I am telling here. Suppose I am telling here same case you take. How much it is? 10 kg. This one you take 5 kg. Now this coefficient of friction how much? 0.2. Now force is acting where? Force is acting support to the lower block. Force is acting to the lower block F. How much it is acting? It is acting 50 Newton. How much? 50 Newton. Now they'll ask, here we find the acceleration of 10 kg. Acceleration of 10 kg each. Right here, each dash meter by second square. Yes, ma? Listen first, listen. Here what is happening? Actually, if this total system you will check. In this system, if force is acted to lower block, what is Fx max condition? Tell. F max condition is m1 plus m2 into mu g. If you apply m1 plus m2 value, how much? 15. So 10 plus 5. Whatever. So total I'm writing. So it is 15 into 0.2. So it is 15 into 0.2 into 10. How much is coming? 30 Newton. So maximum force to move together is how much? 30 Newton. That means if you are 30 Newton applying, then this both block will move together. If we less than 30 Newton also applying, both block will move together if this friction is able to move these objects. So if it is greater than 30, that means here this applied force F is greater than F max, then what will happen? Now they both will not move together. They both will not move together. They will separate. So 5 kg will separate from the 10 kg and 10 kg will move individually. Are you able to understand? They both will not move together. Now here what you do? Now here 5 kg, for 5 kg free body diagram what? Now for 5 kg frictional force will act in this way. Okay, because frictional force will help to move in this direction, right? That's our things actually we are giving. And here next is F equal to this much and acceleration take. Here acceleration suppose A1 and frictional value you know already. So frictional value how much? That is equal to 5 into A1. 5 into A1 and frictional value already you know, that is how much? Mu into 5g equal to 5A1. Okay. So 5 kg acceleration you find. Now for 10 kg you come. For 10 kg what is happening? Now this is your acceleration A2 and here force is acting this direction F, that is your 50 Newton, and frictional force which direction acting? Frictional force opposite, right? This way. Frictional force how acting? In this direction, right? How much it is? F, and it is moving this direction. A2 direction. Now acceleration you want to find means what you have to do? Now just apply Newton's law. So 50 minus F equal to how much? 10 into A2. They are asking a 10 kg block. 10 into A2. Now here what is happening? Check. So it is your 50. 50. Now tell here you want to find what? You want to find A2. F value how much? Tell ma. F value. F value is how much? Tell. Mu 5 into G. Okay, because for 5 kg only F you will calculate, because normal reaction N is on this in this direction and mg is downward, so F equal to 5 mg. So mu equal to how much given? 0.2. 5 how much? Tell. 5 is 5, G is 10. So total how much coming? 10 Newton. Yes or no? Is it clear or not clear? 10 doesn't cancel, 5 into 10. Now here you can write 50 minus how much? Frictional value 10 equal to 10 A2. Now 50 minus 10 how much? 40 equal to 10 A2. Then A2 how much coming? 4 meter by second square. Yes or no? 4 meter by second square. That means if you give it 10 Newton, what will happen? Now both will move together for some time, just for some time. This acceleration will go, maximum acceleration for this A 5 kg is how much? That is mu into G. Okay, mu into G will come, whatever you told. How much value you told? 1 something, 2 you told. So 2 will come. So A1 you want to find means A1 is nothing but that is mu into G, that is 2 meter per second square. Okay, but after that this will separate from the 10 kg. Then 10 kg block will move with how much speed? Sorry, how much acceleration? 4 meter per second square acceleration. Yes or no? This much idea you should remember. So remember, whenever this force, applied force is greater than your F maximum condition, that time what will happen? That time both body will move separately. So both body will move separately. So in this condition, what is happening? Now both objects are moving separately. Okay, so this much you remember. Okay, now we'll go to some another type of questions. We'll see some change in momentum questions. Okay, this much you remember for friction. Okay. What? But before that, just one thing understand in NLM, that is very important part. That is a pseudo force concept. Okay. Okay, one pseudo force concept, direct question I am telling you, just remember. From pseudo force, remember directly. Is it completed, everyone? Okay, completed. Done. Now listen. So in terms of question, you try to understand this. Right here, it is a NEET question. So what they're telling, a cat is here. Okay. Now here, this is called. Now here, what is happening? One block is here, just attached to here. Block is attached to here. This block mass is how much? M. Now this total system is going with acceleration alpha. System is going to acceleration alpha. So what they are telling? Now the value of alpha, or the condition on alpha such that block M will not fall from cat. This is the question they are asking. Okay, options are given. Tell here it is given alpha greater than equal to G by mu, and option B alpha less than equal to G by mu. Option C, right, alpha greater than equal to G by mu. Option D, right, alpha less than equal to G by mu. This type of conditions are given. Yes or no? Did you understand question? Okay. Now see here, actually whatever Newton's laws we did, that one we are doing in terms of actually inertial frame of reference. Okay, inertial frame. and friction also used. Here what I am telling here, listen ma. Suppose this object is moving with acceleration alpha, and here if one observer is there, here one observer is there, this observer O2 is called as non-inertial observer, non-inertial observer, NIO, or that is called as non-inertial frame. And if a person is standing here on road is not moving, right? So this is called inertial observer. What do you call? Inertial observer. This is your O1. Yes or no? Now when you are applying Newton's laws of motion for non-inertial observer, that time you want to apply one pseudo force. What do you want to apply? Pseudo force. But for O1, no need to do anything. For inertial observer, you apply Newton's law, no need to do about anything about pseudo force. Okay, normally you do. But here, when you are non-inertial observer, that time you want to apply one pseudo force. Okay, now this is your observer, and this observer is moving with this acceleration alpha. That's why this observer acceleration is not equal to 0. But this acceleration is 0. So for the observer, acceleration 0 means it is inertial observer. But the observer acceleration is not equal to 0 means it is non-inertial observer or non-inertial frame. Okay. Now for this observer, if this will observe this mass m, then it will apply one pseudo force on this mass m. How it will apply, I will tell. So first we are doing for this O2. So free body diagram you do for m. So what is the free body? There itself you do. What free body diagram? Now this observer will observe that friction for this one. See, it is actually there means it will fall, right? So gravity will be like this. No worries. Gravity is like this. Friction will be upward. So friction is upward, no worries. Because gravity is pulling means it is coming like sliding here. And here between this cart and this block, that coefficient of friction is given how much? Coefficient of friction is given mu. Remember, friction is there. Okay, and remember mu is nothing but what? Mu. Now mu is coefficient of friction between what and what? Coefficient of friction mass between cart and block. Okay, so this is given. Now listen here. This for O2 what I told? I told you to apply one pseudo force, and here normal reaction due to the surface, one normal reaction will come this way. This is okay, no worries. Now pseudo force to apply. Pseudo force I am applying with a different color. See here what I am doing. Now here, if pseudo force you are applying on this object, this is the object, this is the observer. What you do? Now you see what is the acceleration of observer. Which direction? Rightward direction. So pseudo force you apply opposite to the acceleration of the observer. Yes or no? Clear? And next thing is, what is the magnitude of this pseudo force? Now to whom you are observing this object? Now take object mass, how much? M. And what is the acceleration of the observer? Now put that alpha, m into alpha. Is it clear or not? So always remember, pseudo force when you are applying, pseudo force you apply when you are observing from a non-inertial frame. And when applying pseudo force, that time your pseudo force direction should be opposite to the direction of acceleration of frame, non-inertial frame or observer. And what is the magnitude of the pseudo force? Now force means it is mass into acceleration. So mass of the object into acceleration of the observer. Mass of the object into acceleration of the observer. Now m alpha. Now listen. Here what they are telling? They are telling you find the condition so that this m will not fall. M will not fall means what? This f should be equal to mg. F should be, if f is suppose less, mg is more, then it will fall down. Suppose this pen is there, two forces are there. Here one force, here one force. Now if this down force, this my hand is giving down force, right? If down force is more, pen will go down. If up force is more, pen will go up. Similar type, understand? If down force is more, this will go down. So that's why if both are equal force, that means what? Pen will not fall. Otherwise, if friction is more, that means if upward force is more, then also pen will not fall, or that mass will not fall. That means what is the condition? Now condition M not to fall, not to fall. What condition coming? Condition is coming, F should be equal to mg. Also, F can be greater than mg. And one word, if you will combine these two, how will write? Friction should be greater than equal to mg. Now friction force, what? You know it is mu times normal reaction. That is greater than equal to mg. And n is what here? See, vertically there is no motions because there is no acceleration vertically in this direction. Sorry, horizontally you tell here. Okay. So why no acceleration? Because when you are on the car, you will see that this M is sticking to this car. M is not moving this direction or this direction. So that's why what will happen? Now here n equal to how much? N equal to m alpha, which is greater than equal to mg. So remember here. So here you are getting here. Now here you are getting n equal to m alpha. Remember this. Because there is no motion when observing from here. There is no motion in this direction or in this direction. So that's why these two will be equal. N equal to m alpha. Now what will happen? M cancel. Now what will get here? Alpha equal to greater than equal to g by mu. What is your answer? Answer is C. Yes or no? Okay. But remember, if you are solving based on this, observer 1 also will get correct answer. Observer 2 also will get correct answer. But think when observer 2 you are doing, you should apply pseudo force. But for observer 1, no need to apply anything, direct answer will come. Okay. Did you complete it? That is your NEET 2010, I think 2010. Okay. Now listen, if observer with respect to observer 1 also do same thing will come, but remember here no need to write m alpha. But see, if observer 1 what will follow now this contact surface, no, that card contact surface and block contact surface, your normal reaction this way, right? So this normal reaction is responsible for motion in this direction, right? So that is mass times acceleration. So n equal to m alpha coming, and other thing will be similar way. So with respect to O1 also you can do. But here m alpha no need to apply, directly you can tell n is the responsible for motion in this direction. So n equal to nothing but force equal to mass times acceleration is alpha, so acceleration m alpha. Clear? Yes or no? So here friction based application on the pseudo force you are understanding. And remember pseudo force when you will apply for when you are observing from non-inertial observer. Okay. And pseudo force, what is the magnitude? Mass of object into acceleration of observer. Okay. And the direction is what? What a direction of pseudo force? Opposite to acceleration of observer. Opposite to acceleration of observer. So this one you must remember. Okay. So pseudo force is applicable for non-inertial observer when non-inertial observer is observing this object. This observer object. Then pseudo force how you will apply? Now magnitude is mass times acceleration of the observer, and mass is nothing but mass of object, and the pseudo force will be always direction is what? Opposite to the direction of acceleration of observer. You got stock down. Talking fellow. Talked here.